So hello, everybody. I hope you're not tired of seeing me. Wait, it's on? It's on? Can you hear me? Okay, great. Okay, so in this session, I'm going to talk about OceanProtect, which is our new Flash-native backup storage. So I'm going to first talk about the trends in data protection in general. Then I'm going to talk about the feature of our new OceanProtect backup storage. And at the end, I'll speak about some of the ecosystem and a success case. Let us start. I guess all of us are aware of the huge data growth. All the morning we talk about the Iota age. So definitely, the amount of data are growing exponentially. Just looking at a single autonomous vehicle, it will produce 64 terabytes of data per day. This means that we need to cope with this problem of growing data. Why do we need to back up the data? This is pretty clear, but I'll go over it. First of all, there are natural disasters like floods, weather, fire, and the above. Then there are viruses, ransomware. I think it's the hottest word today. Like the previous guy said, 150% increase in ransomware just in the last year. It's a very good business to be in. Unfortunately, we're the good guys, so we cannot provide ransomware, but, but at least we can protect from it. Software and hardware failure, no matter how many nines we have, there can be power outage and failures happen. Then there can be human errors. Someone can delete a table. There is one example here, but in Israel there is a famous case where the bank deleted one of the tables and the replication was on, and then all the services of the biggest bank in Israel because of this mistake were down for almost 1 week. So why do we need a dedicated backup storage? Okay, why wouldn't you use like a standard storage? So first of all, 1/3 of the enterprises today do not meet the backup window. This is why we need our backup storage. The pointer. Where is the laser? Oh, no. What did I do? What did I do? And where is the laser pointer here? Sorry. No, I haven't put one. I will just move forward. No, back. This one. So where is the laser here? Okay, thank you. Sorry. Okay, so since 1/3 of the enterprises do not match their backup window, we need the backup storage to have ultimate performance. Then the data grows by 50% year over year, but unfortunately, your budgets are not growing so fast. The budget is increasing by less than 10% year over year. This is why we need the best-in-class data reduction techniques. Last but not least, Gartner says that already 30% of the users use the backup copy for other purposes, such as analytics, test and dev, and other use cases. This is why we need the backup storage to also have high IOPS. It's not enough to have a backup storage that you can just restore the data. You may want to use the data. Traditionally, if we look long time ago, it was tape to tape, disk to tape. The production was running on HDDs. The backup was running on HDDs. And then the archive would be on tape. This is not good enough. The backup windows were too high. The recovery time objective were too high and not predictable. And then if the backup job didn't succeed in the night, restarting it in the middle of the night means that during the day you will never finish your backup. This is why we think it's time to move to flash to any. Okay, in primary storage we already moved to flash. Everybody is already there. We claim that it's time to move the backup to be flash-based. Obviously, the archive should be anywhere. It's not enough just to archive to tape. We need to be able to archive to another data protection system, or to the cloud, or to tape, or to Blu-ray, or to whatever, wherever you can put your data. Why would we want the backup storage to be all flash? First of all, the performance is much higher, 5 to 10 times higher performance, even when it's backup storage. And obviously, if you want to use your backup for test and dev, you need this performance. Then the total cost of ownership actually reduces because the power consumption is lower. The amount of disk return decreases, and also the fact that you can use the storage for other purposes, and now you don't need a special storage for your test and dev, means that the total cost of ownership is actually reduced. And of course, the reliability. Flash devices are more reliable than HDDs. Let us look at the Huawei OceanProtect storage. Okay, so obviously, after this intro, you understand that this is a flash-based enterprise-level storage. So we have the Dorado primary storage. We have the OceanProtect backup storage, which is flash-based enterprise storage. And then through OceanProtect, we can replicate and archive the data everywhere. We can use our storage replication to replicate to another OceanProtect node. We can transfer the data to an object storage, such as Ocean Pacific, and transfer it to the cloud, and we can move the data also to tape. So why do we say that this is an enterprise storage? First of all, the backup speed. The backup speed is the highest end-to-end. We also support instant recovery due to the fact that we have very high IOPS in the storage, as we will see in the next slides. Then we have the state-of-the-art data reduction. Like I said in the keynote, we get to 72-to-1 data reduction, and I will give you a deep explanation on how this data reduction works. And last but not least, we have the highest reliability, whether it's the data consistency checks that happen in the background, and if it is the system reliability and the proactive orchestration and management. So first of all, let's look at how we use our hardware to accelerate this system. So from front end to back end, the OceanProtect is optimized. At the front end, we have our DTOE NICs, which have protocol acceleration and allow the best access, the fastest access to the storage. Then, inside the storage, we have intelligent CPU partitioning, and we leverage the multi-CPUs in the best way possible. And when looking at the back end, we have optimized algorithm. We have our own flash palm devices. And basically, we write the data in full stripes to allow a reduction of the write amplification and make the devices available for a longer time. Regarding instant recovery, I told you that this is a storage that allows you to run production-grade workloads to do test and dev. So if we compare to our peer product, I will not say the name, but everybody knows which is the biggest product currently in sales in this area. You can get 60,000 hours per second in the biggest system. When you're using OceanProtect X, even if you use the mid-range model, the OceanProtect X8000, you'll get 160,000 hours per second. And if you use the high-end OceanProtect X9000, you also already get like almost 500,000 hours per second. This allows you already to run almost production-grade applications and run your test and dev. Obviously, we have all the features that we have in our enterprise storage, such as clones that allows you to actually run the data and write the new IOs to temporary space so that you can then revert it, but you can run the application against our storage. So why would we need the extreme data reduction? Why wouldn't we recommend you, for example, to use OceanStore Dorado, which also has a great data reduction? Why do we need dedicated data reduction for backup storage? So the reason is that when you do a backup workloads, you back up again and again the same data, maybe with minor changes. Over time, 1 petabyte, I don't know, after 90 days of daily backups, we'll get to around 12 times bigger amount. This means that more capacity, more rack space, more power consumption, and overall higher TCO. Leveraging our dedicated OceanProtect storage with its optimized variable length deduplication means that you get much lower total cost of ownership. Okay, I spoke so much about data reduction. Maybe now it's time to really explain how our data reduction works. So basically, we have a pipeline of data reduction which has 4 steps. You write the data to the storage. Basically, the storage can expose you a file system. You write the data to this file system. And then basically, the first step of deduplication, of data reduction happens, which is removing headers and separating between the headers and the data. Keep in mind that typically you will not just write to the storage, you will use some backup software such as Commvault or any other backup. This backup software would add a lot of headers to the data, and this will actually harm the deduplication. After we separate the headers from the data, we use our multi-layer variable length deduplication. So variable length deduplication is very common in backup storage arrays. I'll explain later what multi-layer variable length deduplication means and how it helps us get better data reduction. Then we have our own feature-based data compression, which is highly optimized. And last but not least, we have our byte-level compaction, which means that we keep the data very compact and not waste space after the blocks are compressed. Well, this is how we get to 72+1. Obviously, not every workload will give you 72-to-1 data reduction. The test case here was 200 VMs in a virtualization scenario with full backups for 28 days. Let us start with the steps that we have, okay? Basically, you have your environment backup. You have your backup server. Let's say, again, Commvault would be here a choice of backup software. Then Commvault looks at the changes that you have. It adds some headers, and then we do the variable length deduplication. The problem is that the headers, even if the data is barely changed, we have headers every some amount of data, and the headers do change every time. They have some timestamps inside. So when you do the variable length deduplication, you will not get the optimal ability. What we do in OceanProtect Backup, we basically separate the headers and write them in a different location. And then we do the variable length chunking for the data. And then we get like the state-of-the-art deduplication ratio. Moving to the multi-layer deduplication. So basically how variable length deduplication looks for some familiar areas in the data and decide them as a cut point. When the data entropy is high, meaning the data is random, sort of, it means that we don't have very often potential cut points. But when the entropy of the data is low and the data has a lot of repeats, we may have a lot of candidates for cut point location. Now, standard storage arrays that do backup will select the first cut point that is suitable. But in our storage, what we actually do, we check for multiple such points, and we will select the points that will give us the highest deduplication ratio. And by leveraging this technique, which is a little bit more CPU intensive than standard variable length deduplication, we can actually get 10% higher deduplication ratio. Moving to the next step, it's our feature-based compression. Basically, if we look at the industry standard like LZ4, which is a very fast algorithm that gives not the best-in-class compression, or move to gzip, which is also kind of a standard and give like better compression, but at a higher cost of performance. Obviously, there are even a better compression algorithm, but they are too expensive to use in standard data. Our algorithm, HZBC, is a proprietary Huawei algorithm. It actually gets 14% higher compression than gzip, but performance-wise, it is comparable to LZ4. So you get 57 higher compression ratio at LZ4, but using the same amount of CPU. One of the points of this algorithm is that it actually does some pre-analysis of the data and separates the data into multiple streams, and for each stream, it will apply a slightly different algorithm. Then the last part of our data reduction pipeline is the byte level compaction. Typically, most storage arrays will do compaction at the kilobyte level, for example. Meaning, for example, in this example where we are looking at fixed block size, but in a variable length deduplication, it will probably be usually different size of block, but each block is being compressed. But then when you write it to the disk, you actually round to the next kilobyte. Okay, this means that for every block, there is a waste of 0 to 1 kilobyte data. On average, it's like 500 bytes. But in Huawei pipeline, we actually have byte-level compaction, meaning we compress the data, but we round the data to the next byte, meaning on average, you will lose 4 bits per each block that you compress. And this gives us a waste of less than 1%. It seems that maybe it's trivial to change it, but it's really not trivial because it changes all the mapping inside the storage. And if you didn't design it this way from scratch, it will not work. So this is how we achieve the 72 to 1 data reduction. Again, I repeat a little bit what was said in the previous one about the diff and diffx are standard mechanism that allows you to keep 8 extra bytes for each block of data, including CRC, including some application information that can be used by the application as a standard, and some reference tag that lets you know that the data is indeed in the correct location and there was no mix-up in the writing. We support it. In addition to that, we have some stripe-level verifications that allows you to understand about, not just about a single block, but about multiple blocks, and also verification for the metadata. What happens is that the system on the background is scanning the disk, looking for errors, and if there is an error, usually you can fix it with the erasure codes. Obviously, if there is a very big error across multiple disks, you'll not be able to fix it, but 99.999% of the cases when there is already an error, you'll be able to fix it. This leads to a much more available storage system. Next, our system, unlike any other backup system, is an active-active system. This is a big value both for performance and for availability. For performance, we do load balancing, like was described in previous sessions in Dorado and Ocean Pacific. We can do load balancing and get higher performance when you have multiple controllers. But also there is an online failure. When you have a traditional backup storage, which is not active-active, when the controller fails, the backup will fail, and then you need to start the backup from scratch. Here, when one controller fails, nothing happens. The backup engine doesn't even know that something happened because there is an automatic failover, and the backup process just continues to work as if nothing happened. On top of that, we have the highest disk reliability. We support the RAID triple protection. This means that if 3 disks fail, you still don't see any problem in the system. The system continues to work. Obviously, when the 4th disk will fail, we will have some data loss, but until such a disk fails, up to 3 failures, we support it. Our competitors support maximum 2 failures. So obviously, when the disk fails, you can replace it online without changing anything, and the disk will be rebuilt. Next, our data management engine, DME IQ, allows you to shift orchestration and management from being reactive to being proactive. First, we have our intelligent forecasting. So basically, we can do capacity prediction and tell you, look, within 3 months, your system is going to run out of space, meaning you need to buy some more space. Then there is a disk failure prediction based on machine learning that lets you know that a disk is probably going to fail, even though the disk is currently working perfectly, but from monitoring some information about the disk, we can understand that there is a high chance that the disk will fail, and we tell you to replace this disk, and then you will not see the failures at all. Then there is the intelligence analysis, which allows you to do a performance bottleneck analysis and give you optimization suggestion. And of course, we have the mobile application, which allow you to monitor the storage and manage it from home. I don't know if you want to do it, but it's possible. And we are back to ransomware. OceanProtect has a 5-layer of ransomware protection. First level is storage encryption. This is good against data leakage. If someone steals one of the devices, he will not be able to read from it. Then there is the SMB encryption, allows you to encrypt the protocol and not letting anybody eavesdrop on the net. Then we have two features which are similar. First one is secure snapshot, which allows you to take a snapshot which is read-only and cannot be modified or deleted for a specific point in time. This is like a foolproof protection against ransomware. If you have this snapshot, no ransomware can change it for as long as it exists. We have the worm file system, which allows you a similar feature. Worm means write once, read many. It allows you to protect deletion and changing of files or directory in the same way for a preset period of time that you choose. But once you chose this period of time, no matter what you do, even the administrator cannot delete this data. Then there is the support for air gap. Basically, when you replicate between two OceanProtect systems, you can put an air gap. Air gap is a physical difference between the two nodes. The air gap link is open only during the replication time, which can be very short time during the day. And the rest of the day, the remote system is not accessible and no ransomware can touch it. The evaluator group looked into our storage. Keep in mind that the results here are comparing between a high-end backup storage from another vendor compared to a single node X8000. So if you will take here the high-end 9000, the gap will be significantly higher. But I think that this is a good enough gap. So when we are looking at the backup and the restore speed, so on Oracle, we got 2.6 faster backup and 2.3 faster restore. On VMware, we got 2.4 faster backup and 1.7 faster restore. Then we compare the data reduction. For Oracle, we got 43 times data reduction for the workload that was chosen, compared to the other vendor, which was 28.1. And for virtual machine data, we got 29.3 compared to 19.7, meaning we get like 50% higher data reduction. This is a significant number. And obviously about reliability, here there is no surprise. You didn't need even to check if you read the specs and believe it. Having a RAID triple protection compared to any RAID 6 gives you much better availability, because if 3 disks are moved from a RAID 6 system, which our competitor have, obviously the system will stop working. Let us move a little bit to the ecosystem and to some success cases. So basically, this is a backup storage. Our family have 3 models, the high-end X9000, the X8000, which is the mid-range, and the X6000, which is more lower-end. We support any backup software. Veritas and Commvault are officially supported, and there is no need to ask our sales for evaluation. If you want to use another software like EMC Networker or IBM Spectrum Protect, you need to contact our sales. The protocol supported, or any protocol is supported for backup, but the recommended protocol is NAS, so exposing file system and writing the backup to the file system. But Fiber Channel and iSCSI are also supported. Again, if you want to use them, better contact our sales. Let us look at one success case. So I'm not allowed to say the name, but it's a large, very large Chinese bank that reconstructed their backup service. The workload they had was the SQL file system and VMware. They used the backup storage with VTL. And over SAN, they moved to using OceanProtect over NAS. The only change they needed to make in the environment is actually to connect an IP cable to the OceanProtect. The backup speed increased by 100%, and the active-active architecture solved the problem that they had, that sometimes a small failure in the backup storage caused them not to be able to back up and finish the backup in the night. So that's all. I hope you enjoyed the session. Thank you very much.